Hello guys, it's Petro TV here and continuation video to the previous introduction that I have done. And in this video we're gonna cover plotting. So if you are more of an advanced user and beginner, you want to know how you can get the best setting out of your system and stick around. So first of all, in order to get the details of your system, press Ctrl Shift Escape. That will bring up the task manager. Okay. So only here you want to press the performance tab, and in the performance tab it will show you the CPU, memory, and the drives that you have. When you do plotting, there are some rules that you have to remember. Okay, you need to have minimum of 16 gigabytes of RAM or more. You have to have a separate SSD. Can't have SSD with your operating system on it. Meaning Windows. You can't use plotting the same drive. I'll get to that in a second, and we'll cover more details. So first, let's focus on the things that you currently have. Okay. So I want you to take a notepad, open up a notepad. Okay. I'd create a notepad, but I haven't. Okay. So take a notepad. I note some things down. So you need to note the logical processors, how many you have. Generally speaking, 12 threads, okay, is divided by 2, okay? Logical processor equals the number of plots. Because each plot takes around 2 threads, which that sums up to 6 for me. Very simple. So you can run 6 plots. For my system, I'm running 7 plots. It's not optimal because I run one more. My solid state drive is 2 terabytes, meaning it's 2000 gigabytes, and it can take on more plots than 6. And I want to get as much benefit as I can from that drive because I don't want to, it to be idle. It's wasted space, not used space. If you want to use 6, you can use 6 for a 2 terabyte drive. If you have a 1 terabyte drive, then you can go calculate. So the thing that you have to calculate as well is the storage. If we go back to the add Chia client, go to add plots, and the Gibbs temporary space, that's the temporary space used. If you have older client, it may show that you need 300 something gigabytes, but in the more recent version, you require less because it's more optimized. So if you look at the 239 Gibbs, actually gigabytes because there's I in the middle. So that actually equals to around 256 gigabytes. So what you do is do 256 gigabytes times by number of plots, and that's potentially the maximum storage is going to use. Okay? Not guaranteed that's going to use it, but it's potential that if, let's say, all of them end up at the same point running, say, and uses up all of the temporary space, you could freeze up the whole process if you don't have enough space. So that's why you have to calculate if you're going to have space. So let's go into calculator, and we're going to multiply the storage. And my calculator is taking time. 256 times 7. We're calculating the gigabytes. Okay. And that's 1792. Okay. My SSD has 1.8 terabytes, which is around 1800 gigabytes, which is just enough. Okay. I'm currently running 7 plots, and as you see, it's not using all of the space, but I don't want to risk it by putting the 8th plot, or I would not recommend that because there's always a risk that it will freeze all of your plots and it will stop working and you're gonna waste your time. For example, if I went to my plots, they're currently running. If you add up all of the percentages, I would probably lose around 3 plots because my system corrupted. So how much did we get? So 256 times 7, and that's 1792. So let's just save that so we can have the details. So if you notice, let's say you have 12 threads, divided by 2, you can run 6 plots. Okay, that's an optimal. More than that is gonna put extra stress on the processor. I'm doing this because I want to get the full advantage of the 2 terabyte. You don't have to do this, you can just run 6 plots. Okay, so if you notice that, let's say you have 1 terabyte but you have a good processor, that's the thing that will be your limit. You're being limited by your solid state drive. So you have a 1 terabyte SSD that has normally 920 gigabytes, 1 TB SSD, because the for processing and formatting gives you less, so you have 10% less than actually shown on the box of the SSD. So you can probably run, let's calculate this, 256 the 920 divided by 256. Okay, so you can run 3.5 plots. Could potentially get away with running 4 plots, but it's up to you. You can run 3 or 4 plots. Add that storage, okay? Going next, what we need to consider, RAM. So the RAM is key thing as well. So let's just assume that you have 32 gigabytes, you have a 12 thread processor, you can run 6 plots easy, you have 32 gigabytes RAM memory, and that's pretty much it. Just can run the plotting easily. But how much do you assign? Like when you go to add plot, how much memory do you actually assign? The plot can use up to 6750. Anything beyond that, you're just locking up memory and is wasted. You're not going to be anything more than 6750 is just wasted. Okay, it's no computer is not going to need to benefit from that. So you know how much is the maximum, and the minimum that, I mean, the starts is called 3390. So if you're running 6 plots and plus 1, so let's say we're running 7 plots. We're running 7 plots, okay? I'd say normal setting for this is around 3800 or 4000. I run 4000 and it's working, okay? If you notice that your computer is running slow, or if you want to run the browser, I'd say 3800, so times 7. So let's say 3800 is the safest. If you plan to use the don't plan to use the computer, you increase it a little bit to 4000. Okay, so that's in MIB. MIB, of course, is less than a megabyte, so this will be around 28. So you're looking around 27 gigabytes of memory. That's just an estimate, okay? So 27 gigabyte use. But I will show you that Windows by itself, I mean, of course I can't see it here, but this portion, there's a portion. But let's say you are not plotting currently. Go to your task manager by clicking Ctrl-Shift-Escape and Performance. You'll notice there's nothing running. There's 4 gigabytes used. Because Windows itself passing on information for that memory, and it needs to function. So you're gonna have less available memories. Add the 4 gigabytes, 31 GB. This is just worst case scenario that all of your plots use all of that memory at once. Of course, you can see it's not using at the same time. Okay, could go for 1000 MIB setting. This was at us doing it at 3800. Okay, let's just stick to that for now. And that's for 7 plots. Okay, you were to run, let's say, only 4 plots or 3 plots, you are only capable of running 3 or 4 plots. Okay, so 3 or 4, let's say to 4, have much more memory available. So let's say we do 6750 times 4, that's around 27, very close to that. So there will be like 27 and a half, which is okay. Fine, run it like this. I'd say with 3 would be more safer. Maybe just to be on the safer side, put 6004 or 6500 for. Yeah, it's more safer, closer to this number. So that will be 26.5 G worst case scenario, and that was at 6500 plus 4 gigabytes for Windows equals around 30.5 G. So you're not over your actual RAM. That's 4. Okay, and like I said, this doesn't mean it's going to use that memory. This is just a worst case scenario. Like you can see, I have 7 plots. Should run around 28 memory, but it's not because they are different stages. I will get to the stages in a second. So this is 26, and let's just 3 again. So 3 times 750. You probably got hang of it by now. You don't want to do more, like I said, otherwise it's wasted resources. Let's say try to run internet or browser on your, it will freeze up the computer. You don't want to use more than that or wasted resources. You want the computer to have room to breathe, and the more the better. That's pretty much. So you can see that that's gonna be around 21 gigabytes. Worst case scenario, using at the top, like the most memory that I can use. That was 6750 plus 4 gigabytes was the total of 25 gigabytes, and that's for 3 plots. Why do you want to do this? I mean, work this out. I mean, I can work this out in my head, but as you're a beginner user, you might want to do it on, like, on paper, or you want to do it in a document. Okay. So I run 6 plots because my SSD. I mean, I do 7 plots because my SSD fits 7. Okay. So now we will get to the bit more complicated. The big thing that you will notice that impacts your performance is SSD, which is solid state drive. You can do plotting in hard drive, mechanical drive that has a spinning disk, or a solid state drive which has memory chips on it. The only two things that you have to remember, both of them wear out. Hard drive becomes slower over time, and SSD sometimes gets either errors or just dies instantly. And best SSD to get that has a lot of endurance, so meaning terabytes written. But this will I cover into another video because I will get into too much details. That's why I say you need to do testing. Let's say you run 2 plots. Okay, so with the settings provided, okay, the same scenario will work for the 16 gigabytes. Okay. So before I jump into the add plot, let's quickly work out the 6 gigabytes for beginners. So 16 gigabytes, and you're running 7 plots. You can't run 7 plots because if you look, even at lowest setting, which is on here, 3390 times 7, that takes you over 24. It's impossible for you to run 7 plots on the 16 gigabytes. So if you do 16 gigabytes of data, of RAM, minus 4 gigabytes for Windows, that leaves you with 12. And how many you can fit on 3390 setting? Okay, 12 divided by 3.3, that's in gigabytes. Plus, this is in MIB, So this is MIB. So let's say that will be around 3.5 gigabytes. Okay, so you can fit 3 plots. The most you can do 3 plots on a 16 gigabytes. So you're looking around say 3390 times 3, that's 10 gigs. Okay, that will be around 11. 10.5. 10.5 GB. Worst case scenario at 3390 plus 4 plus 14.5. That's 3 plots. And if you were to add one more plot, you'll notice that you need 3 more gigabytes. And if you do 14.5 plus 3.5, let's say 3.5 gigabytes, it will be over because it will be 18 GB. But you don't have 18 GB on your PC. This is what you have to pretty much calculate for yourself. And once we've got the settings, go to here. You need to work out the load on your computer. So you would do, let's say, for testing purposes, let's go to Task Manager. So if you have a quad core, meaning that there is 4 cores, say 8 logical processors here, you want to put 3, or if you are 2, and then pay attention to your performance of your computer. So if your SSD is running at 100% constant, okay, then you know your SSD is bottlenecking your computer, okay, meaning that it's basically all of the system processing units like CPU, memory is waiting for the SSD because it's not keeping up. We will need to upgrade. So in order to prevent it is to get an NVMe drive, which is SSD. Normally when you have SATA connection, drive is slow. So I show you quickly how it looks like so you get an idea. NVMe drive. This is pretty much it. You need a special slot on your motherboard to support this, or you can buy an adapter and plug it into your PCIe connection. If you're watching this video, you might know about computers, how to build them. If not, then you need to watch a different tutorial because I'm not gonna cover building a computer. But this is how the slot looks like, or you can put in the adapter like this into slots like this over here, and that will allow you to install those SSD. Okay, and when you have a SATA drive SSD, you notice that they are use connection. These connections are slower and they only do up to 500 megabytes. And you have 2 of these or 3 of these, merging them together into one doesn't give you any speed or performance boost because they are memory chips. They're like memory here. So let's say you have 3800 megahertz, okay, speed of the memory. You don't get, I've got 4 sticks, okay? You don't get 4 sticks times 3800. You don't get like 15,000 megahertz. It's limited to they all work at the same speed. Okay, same that goes with solid states. They will work at the same speed. Generally speaking, they even perform slower than a regular drive. So you try maybe using them separately if you have, and let's say put 1 or 2 plots on one, and on the second one put 1 or 2 plots. Or if you have 2 drives, 1 plot, 1 plot. Of course, these drives are not very efficient because they are limited by the connection. Okay, the small NVMe drives that I showed you just now before, they are much more efficient and they have better connection. The processor, I mean, it's just the bandwidth is much better. The only benefit to RAIDing gets the hard drive because the speed adds up. The big thing that you have to remember, if you storing plots on RAID drive and to plot at the same on the same one, what I'm trying to say is, let's say I have all of these drives together, merged together, okay? And I store them, it's just one drive. Just imagining it to be one disk, all of them merged together into one disk, okay? And I work on this drive and I have the plots here. If there is a catastrophic failure, all of data, I mean, like one of them stops working, all of the plots are lost and all of your work is lost. So that's the disadvantage of the RAID, because all of the data is lost. Unless you're running a special server Linux software that uh, can recover the data, but this is more of a very advanced user. So that's why I don't recommend merging RAIDing the drives together. Okay, so going back to the task manager. So once you analyzed, okay, my solid state drive is good. Okay, I'm gonna cover recommendations of the solid state drives later, so keep an eye out. Subscribe, you can get notified and find out what's the best, or you can do your own research and find what's the best drive. The only thing that I would warn you, don't get the Corsair MP600, because it looks great, but it has very poor endurance according to the manufacturer spec sheet. Okay, it has on a 4 terabyte drive 800 writes, and on 2 terabytes is only 400. What that means is how many terabytes it can write for on the drive. So let's say I've got my Evo 980 here and I've been running it for a week. You can see that it's done 200. One more week and that would be busted on the MP600. So once you identified, okay, my SSD is not slowing down my system, that's how it's running, everything is fine, which is great. The memory is good, I have enough memory, and the CPU, I know I calculate how many plots I can run. That's pretty much it. There is nothing else to it other than just setting up the settings. The only thing that is left outstanding is the delay. The delay is that you calculate when you do the testing. So once you find out that something is slowing down and you know you can't upgrade a computer, and you just run with whatever you have, then what you can do is just say rerun 2 plots with a SATA drive, which is the standard connection, not the small drive, the slightly bigger like a hard drive. Let's say you run 2 plots and that will tell you the speed. So where you can find the results. Okay, so I have 7 plots running, and you can, like I did in the previous video, you can check the logs by pressing those 3 dots, view log, and you go to let's scroll down. It will show you the phase 1 and phase 2 time. So this normally you get these results after 32%. So the easier way to access it, you can click on the folder, click on this PC, your C drive, which has your operating system on it, user .chia, mainnet, plotter, and anything that's 203 kilobytes, that's a finished plot. But of course, you won't have finished plots by if you're just starting. So let's say this is 63 kilobytes. This is gonna keep on updating itself, and if you scroll down, this one has started phase 2, but hasn't given us the total time for the phase. So let's take one of the plots that have done more progress, and we scroll down to that point. You will notice there's a big break in the list. Oh, I missed it. Oh, I was going too fast. How did I miss it? Okay, let's try this slowly again. There we go. So the way you would set up the delay calculator, 15538 plus this is the that you get the total time. Okay, copy that over. Plus, you don't want to wait for the whole plotting if you want to just be quick with it. Plus that, and divided by 60 because the results that we have in that file are in seconds. Divided by 60, 351 minutes. Divided by 60, it's 5 hours 85. So multiply by 60 to get it back to minutes. Okay, and then multiply it by 2. So then divide it by 60. As you can see, it's around 11-12 hours, which is pretty bad for my results. Okay, so let's say this is your actual result for the plotting. Okay, and we are doing 7 plots. So we know that 2 phases take 5 hours and something. We multiply the result by 2, so it's 5.8 times 2. Okay, and that was given us the time. So let's check how accurate this is. We scroll down to the bottom of a finished one. So I'm gonna close these. I'm gonna go to the finished plot, and if it's accurate. Okay, this is the finished total time on here, and divided by 60, divided by 60. So we are almost close to it, but this one of the pressure plots, meaning that when you start plotting, the first plots they have lots of resources and doesn't reflect the true usage. So let's try this plot. Okay, divided by 60. I mean, it's around 9.5 hours. So I was a little bit off, as you can see. But if you want to get the correct result, is gonna be in the total time. So you could run 2 or 3 plots depending on your system, and run the whole cycle, and then at the end of calculator, or use the first is not it's just an estimate. Some people don't have the time to wait all day, so you can just go by the estimate, go by this. Okay. So the other thing that I want to point out, these plots, okay, have been using threads. Okay, so this is where complication starts. This is the real complication starts. Many users have issues with the Chia client, how to set up the threads. Many say that it's better to have more threads, some have lower threads, context switching, and stuff like that. Basically, what context is meaning switching. So the job pretty much jumps from one thread to another. So you can see that there's a gap because it jumps from one to another. Whereas here, it doesn't switch any. It just has one task and continues working on it at full potential. The only thing is with what I have noticed that the plots, they don't use their full power. You can see that one drops, that one starts working, that one drops, that one starts working, and so on. So what basically happens, they don't work continuously. They have a workload and then they stop. Have a workload and stop. So they read, calculate, read, calculate. So I couldn't understand myself. Why wouldn't you set the maximum? You know, why wouldn't you have them? Because they stop working as well. So another thread. But what basically that does, having a 3 threads on here, it will, let's say it assigns three of them. So let's put it in Paint. It will be easier for you guys. So my computer is a bit slow because recording and plotting doesn't go well together. So let's say one plot is taking 3 threads. So it's taking this one, taking this one. It's done randomly, so, and it's taking this one. So this is just marking which ones are taken, okay? So these 3 plots are occupied by this plot. Then you've got, let's say how many I have currently running. So phase 1, which is under 31%, uses 3 threads, okay? Uses 3 threads. One was 2 threads. But what I'm trying to say is, if you have it set to 3 and it's under 31%, it will use all 3, all of them, okay? Once it's done to over 31%, it uses only 100%. So you can see, let's say here it's using around 1.5 thread, but it doesn't really reflect the threads, you see. That's the problem. And after, once we go down the list, you will notice that the buckets table and the tables are get complete, and it's only 100%. It's only gonna be maximum 100% or less. So it's using 1 thread. So if you calculate, okay, 1 thread, so 1, 2, 3, use that state. So we have 2 plots running at phase 1, so that's 6, okay. And then we have, let's say, 4 more plots, but that they are phase 3, 4, and no, in 2, 3, and 4. They don't use, so they will use 1 thread each. So 1 thread, 2 thread. Let's make it easier. So these are the plots that are using 1 thread each. So 1, 2, 3, 4. Okay. There could be that one of those plots is gonna want to use. Actually, I have 1, 2, 3, 4, and 1 more because we have 7. There's 1 thread left. Could be that one of those plots starts to be on the phase 1 because it was faster. So we'll try to use 3, and they will start swapping out the information. It's very difficult to go into the details, but it's swapping out the information all the time, and it creates the gaps, and the resources doesn't perform as well, apparently. So what I'm going to show you is I have currently the computer running at here. These plots are 12 threads, okay? I set them to 12 threads intentionally. This one as well, 12 threads, okay? And rest of them are, this one is 2 threads, okay? And that one is 3 threads, so meaning how much resources we have assigned to it. So we are at the plotter, and we want to find out this is the 3 threads, okay? The 12 threads, this is the 2 thread, and this is the 12. So we have, it says here 2, 3, 12. This is just for testing purposes, okay? So you don't have to do that, but I'm just showing you the best results. So under load, having 7 plots running, this has completed in 2,383 seconds. That one has completed in 2,121 seconds, and that one under load completed in 1,400. Okay, 1,400 seconds. Even though I have distributed the threads evenly for the threads that I have, it just shows that having all of the threads, because they don't use all the time, like I said, they don't use the resources all the time. They jump up and down. Look, let's all observe a task example here. This one jumps up in usage, okay, and it jumps down. it doesn't use the resources for long. And if you have 12 threads, all of them, when it's its turn, because they swap out turns, it doesn't need a long turn, it just does it quicker. That's what I'm trying to say when using 12 threads. But many people say, nah, it's slower, it doesn't do, I mean, it's performing worse, you don't get benefit from that. But you can either divide these evenly and have 3 threads or 2 threads or 4 threads, like as you wish. But my method, I use the maximum I have available, because from the results that I'm getting, I have a better performance. I set up this just for you guys so you can see the results difference, okay? So that's pretty much covering the settings, okay? That was just the settings part. Now we get on setting up the plotting, okay? So plotting, once we've calculated all of the settings, we are happy with everything that we have. We do, first of all, the best method that I have found for plotting is this. So once you have your delay, okay, so you need to calculate delay. So let's say it was phase 1 time plus phase 2 time. Okay, that was times 2. Okay, so we need to do that. Equals result, which is all 4 phases. That's just estimate. And the estimate divide by the number of plots. And that will give you the delay. Okay, that's pretty much it. So for my 10 hours was around 10 hours, let's say it was 85. I've done it on one other video. It was 85. Just to show you, let's say 10 hours divided by 7, that's 10 hours. We do it into minutes by 60 because there is 60 minutes in an hour, 85. Okay, so that's our delay. And before we use this delay, we set up the settings. So we look at the table that we have created. Okay, I have 32 gigabytes of RAM. I want to use 4000 because I know that I'm confident that it's not gonna peak at the maximum. I can see I've tested it, it runs fine. So I'm gonna use 12 threads, okay, and leave it as default. That's it. Okay, that's it for plotting. Rest of it we go. If these things you can ignore. But that's under advanced. Okay, so that's where you can find these extra options. So the temporary drive, you want to select it SSD. If you don't have a SSD, you can use whatever you like, a hard drive, but you just remember it's gonna take a long time to process. So I have a drive here, it's called new volume because that's my temporary SSD. I would suggest call it temporary. Temporary. It's asking for permissions. Okay. Let's open that up again, and it's called temporary. See here where the temporary files will go from here. That's going to use to calculate the plot. So like I explained, make the farm plot. You need to prepare it. If you know that you're gonna run out of space, there's always advanced option where you can select the secondary temporary drive. So if you have 2 drives, okay, that will be used if there's not enough space. So yeah, I use E drive. Okay, I use one plot. So just the method that I set up is one plot. Okay, I will explain it shortly, so just bear with me. And the final directory is gonna be either your second SSD. Okay, so second SSD is gives you good benefit because if you think about it, solid state drives are non-moving drives, so the transfer speed much faster because it's from a chip to a chip. If you had a mechanical drive, it would take a long time to transfer. So let's give you an example here. Let's try to say I want to transfer there's here. I've got one plot, which is 100 gigabytes, okay? I'm going to copy it to my temporary drive. I'm gonna do it folder, test, and I transfer from one SSD to the other. Look how long it will take. The calculation saying 1 minute transfer. Okay, let's do the same thing. Okay, to a hard drive. Let's say I want to do it here, and that's doing 13 minutes. So in plotting, if you had 7 plots, times it by 7 plots times, let's say, 20 minutes, because it's doing calculation in background as well. You're looking at 140 minutes times divided by 60, because you want in hours. You can potentially save around 2 hours worth of your time in plotting when having from SSD to an SSD. The only disadvantage is that you have to manually transfer like I do. Okay, the way I transfer it is by right click and you cut. So what that essentially does, once it transfers, it removes it from this final directory, final drive. So that's I call it final because that's my second SSD. You don't have to have a second SSD. You can transfer it directly to your mechanical hard drive if you want. If you don't have a SSD, do it to the drive. So I'm gonna transfer these. So like I said, don't have a second drive, select your temporary, and you can select your external. I accidentally selected my E drive. So what I recommend is for you to have a folder for plots just in case, so you can organize it. And I numbered my drives 1, 2, 3, 4, 5, 6, 7, 8. I mean, yeah, so pretty much I just have it all numbered so it looks nice and I don't get confused. So if I'm doing number 1, then I assign to number 1, number 2. That way I know, okay, number 1 is full. I need to focus on number 2. I need to start filling up number 2. On like number 2 is full, I start focusing on number 3. Okay, and that's pretty much it. So I'm gonna select the final here, and what this is going to do is going to start one of those plots. It's gonna start from 0. And when do you start the others? Okay, so you have to calculate. You have your delay. Okay, we get to the delay in a second. So go to calculator and you go. You have 100%. So one completion is, one plot is 100%. Okay, so 100% divided by the number of plots you're going to run. So if you plan to run 7, okay, you want to have a plot every 14%, not every so often, every 14%. Okay, so we know that this delay is correct. So this will, the total time is 100%. So that, let's say 10 hours is equals to 100%. Okay. But the way parallel plotting works is a bit difficult to achieve the delay nicely. Okay. So when we add the plot, we've set up all of the settings like I showed you earlier, the final drive, and you create that plot. Okay, it will start, and you just wait for it to go to the number that you have set. It's okay if it goes over, or maybe if it's at 10%, you can just continue with me. Okay, you don't have to. Just a guidance. 14, 16, 18, 20%. But this is just a guide. The first plot is important because you don't want to have 2 running at the same time. That's why I found it's overloading the processor a bit. So I know they're gonna be running at phase 1 at the same time, but what I'm going to explain now, add to plot. So once you have that one started and it has achieved that 14%, now you want to do in parallel. What in parallel means they will start working at the same time, but you don't want them to start straight away. So you put the delay. So we calculated for 10 hours 85. Your delay is gonna be different. make sure you have correct one to your, if you want to run nicely. Okay, we set the settings like we have calculated number of threads. I set it to maximum because I have explained that. I set the temporary drive, I set the final destination. Okay, and that's pretty much it. So what this is Paro, you think of it as your workers. So you already have one worker working and 6 workers. They're gonna be coming in one by one, delay 85. Reason you want to delay it, because take a look at my processor is running almost 100% and it has few plots at under 31%. And under 31%, that's when the most of the usage is of the processor. That's going to slow down all of your plots. So you want to distribute them and space them out so they don't get slowed down by each other. That's why you want to space them out so they get complete fast and they crack on doing other things and you don't need to worry about them. So the reason why we do this way, 6 and 85, and we do exactly the same settings, 4012. And you understand now why we have the delay, select those things again, and then you add to plot. I'm not going to do that because I already have things running on my computer, okay? So you know what's the number of plots you can run based on your computer settings or the availability of resources, okay? So now, once you have those 6 plots running, you will have one, okay? And you will have the second one. Ignore the percentages on here. You will have one at 14%, and the second one will be at 0%, okay? This the 14% is just an example. We have different numbers, okay? Whatever is like I said, will be 100% divided by the number of plots. So if it was 4, you have 100 divided by 100 divided by 4, and every 25% you want to have a plot, okay? But it just as a guidance, you can have it earlier if you want, but you need to bear in mind that it's gonna put extra stress on your processor at a given time, you know, so they're gonna slow down each other. And that's pretty much that. So once this finishes, okay, it needs to have another worker, a task to do. So you have 1 and 6 more. 1, 2, 3, 4, 5, 6. 6 will be here because I counted this. So you will have 6 plots, right? And 1 more. So 7 plots in total, or 4. If you're doing with a less, you'll be doing it with 4. I'm doing an example because it's on my 2 terabyte. If you have 1 terabyte, you will be doing 2, and then you will be doing 1, and then you will be doing 2 in parallel, or you'll be doing 1 and then 3. Okay. And what happens once it hits 100%? Your work, I think of it as a worker. Once the worker finishes that plot, and that one finishes, it will go down to the bottom of the queue and grab the the plot from the bottom and start working on it. That's what doesn't happen in the latest version. That's why we're working with 1.1.2. 1.1.4 doesn't actually continue working through the queue. So you will have 7 plots, okay? So what we want to do is add more plots. So think of it this way. Once your your plots finish, you want them to continue working, okay? So you choose the number of plots, but bear in mind how much space you have available. So for example, go to final destination, and okay, this drive can fit 45 more plots, roughly speaking. So let's go on here, let's select it and do 29, okay? Because 29 is around 3 terabytes. so it's not gonna be any problem. 4012, and ignore that I pressed this, and then you just fill in the temporary directory. This is not going to start anything, okay? There's no gonna, it just add, it's gonna add to the queue, okay? And that's all you have to, just that this is the process that you can repeat. You can keep on adding things. That's the great benefit of the queue. You can keep adding things, keep on adding the job, keep on adding the job. For my instance, it's gonna be the SSD, because I'm gonna be keep on transferring manually things from my drive to external. As you can see, it's currently finishing off, and that's pretty much it. That's the plotting for Chia. It has been a very long topic. I hope this helped you a lot. I wanted to explain this as much detail as I can. In the next video, I'm going to cover the H-pool mining. And please, if you can, subscribe and leave a like, so that will help me a lot. I contribute something from myself to you, and you can help me a little bit by leaving a subscription or a like. So it works both ways, and we both want to work together. So like a friend to a friend, you know. So that's pretty much it. You have explained everything, the calculation, how 12 threads benefits more over than 3 or 2 threads under load. And yeah, if you have any questions or issues, drop down the comments. But please make sure you watch the whole video, because if I put down timestamps, you're gonna miss out the key information that I have done. So I'm not going to put down the timestamps for this video. And yeah, thank you very much for watching, and I see you guys later. And if you're wondering what's going to happen after it finishes plotting, I'm not plotting, transferring these files, I'm gonna leave it here actually for 45 seconds. If you want to stick around and see what happens, or skip the video to that point, then so I'm just gonna leave it like this, so you can see what will happen with those plots. Okay, I want you best if you see it. Beginners prefer to see things. If you're more of an advanced user, you might know what happens. This is where the plots finish. Okay, the finished drive, my drive that I transfer. So if you're going to run it like me and put it on a SSD, you want to make sure you cut it. Okay, and once it's cut, it disappears, because you don't want it there. You want it to be in your external hard drives. Okay, and even if you have a slow drive, it doesn't matter, because you look at your slow drive, like my external drive. So look, I have a F is my full drive. Drive F. Where's my F? F. You see, it's hardly used. So you don't need to worry about usage of the drive. It does it automatically. And like I said, in the next video, I'm going to cover H-pool. So make sure you subscribe and leave a like. And I see you guys in the next video. Thank you very much for watching.